Ever wondered how Netflix knows you will binge the true criminal series at 2 p.m.? Or how your phone predicts you will type pizza before you even think about dinner? Magic? Nope, it's machine learning. And today we are having an algorithm smashdown. Hi, this is Mandira, and let's learn more about machine learning algorithms for predictive models. What is predictive model? Predictive model uses statistical techniques and algorithms to analyze historical data to predict the future outcome. Let's make it simple. Let's take predictive model has a digital fortune teller. Think about it. Your brain already does this. Your friend is always late. You predict they'll be late again. That's predictive model. What's machine learning? Machine learning is a branch of artificial intelligence. It analyzes the data and recognizes patterns. ML models can make predictions and improve over time. There are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning has labeled data with input output pairs. It's like learning with answer sheets. Unsupervised learning works with unlabeled data, finding hidden patterns. Example: detective mode, finding secrets in data without hints. Reinforcement learning learns through trial and error for maximum reward. Let's dive deep into supervised learning. Supervised learning has labeled data, and there are two types: classification and regression. Classification tells us about yes or no, true or false categories into A, B, C. Regression predicts a number. Linear regression predicts continuous numerical values. Logistic regression is used for binary or multi-class classification. Decision tree splits data into branches based on features. It is easy to interpret, works for both classification and regression. Random forest combines of many decision trees, reduces overfitting, improves accuracy. XGBoost advanced boosting technique, highly efficient for structured or tabular data. Supportive vector machine finds the best boundary to separate classes, great for both linear and non-linear problems. KNN classifies based on the closest data points. Simple but works well for small data sets. Naive Bayes works based on naive Bayes theorem and probability. Fast and works well for text classification. Neural network mimics human brain with multiple layers, powerful for complex data like images, speech, NLP. So now let's take three algorithms for our algorithm championship. In the blue corner we have linear regression, in the red corner we have random forest, in the golden corner we have decision tree. Today's challenge: house price prediction. Mission: predict house price like digital real estate agents. Time for the real battle. We have got data set with 300, 3000 housing. Each algorithm gets the chance to train and same to prove their prediction. In this code, we can see that we have imported the libraries like pandas, numpy, matplotlib, cbons, scikit-learn for training and test, splitting data, linear regression, decision tree, random forest, and scikit-learn matrices like mean, absolute error, mean square, r square, and then we are loading the dataset. Dataset is loaded by PD, that is pandas. So we are adding the path of the dataset, and let's just quickly do the data exploration. Using data.head, we can see the top 5 rows of the dataset. In data.info, we can see the structure of the dataset, where it tells us there are 3000 entries and it has 9 columns. Data.describes tells us about more about count, mean, standard, minimum, all the data about the given columns. Let's check if there are any null values. So we use data.isNull function. So if there are no null values, so it's given 0 for all the columns. And if there were any null values, then we have to use this formula where we can fill out the null values by the mean. But here we don't have any null values, so we don't need to fill out. So now let's start the training and testing part. So we need to split the training part and the testing part, where I'm giving the testing part 20% of the data and training part has 80% of the data. Here you can see the test size is 0.2. Model training. I will be training linear regression, decision tree, and random forest for this dataset. We have finished training all the three models, and let's give our own input values and try predicting the price of the house. Here I've given random values for all the columns, and I've already trained the three models, so I'm using those three models again, and let's print out the results. Here we have received three different house prices using linear regression, decision tree, and random forest. Let's evaluate the model. We can evaluate the model using different parameters, that is mean absolute error, mean squared error, RSME, and R square. Using these four parameters, we can tell which is having the best prediction. So once the output is here, we can see that linear regression has R square value is 0.6358, decision tree has R square value of 0.4904, random forest has R square value of 0.7368. But wait, before we crown our champion, let's see the complete scorecard. In this scorecard, you can see that random forest has the highest R score value, that is 0.7368. So we can tell the winner is random forest. But why? Because it has the lowest AME, lowest MSE and RSME, and the highest R square. That's why we are telling random forest is best for predicting for this data set for predicting the housing price. Let's talk about advantages of predictive model. Lightning fast processing, pattern detection, scalable, handles tons of data, no bad days or human bias. Challenges in predictive model, data quality and management. There might be missing data, inconsistency, unstructured data, which reduces the accuracy of the model. In our previous example, you can see that there were no missing data. Model interpretability. Models are harder to explain. Overfitting and underfitting. Overfitting learns noise, underfitting misses key patterns. Ethical and privacy concerns. Using personal data risks privacy and ethical issue. What are the real world applications? Predictive disease outcomes, fraud detection, stock trading, personalized recommendation or cart management, predictive tool maintenance, energy consumption optimization, autonomous vehicles, that are all our future tech, AI model cars which work on themselves. Thank you so much for staying tuned. Hit the like button if you liked the video.